Alright, so good morning class. So I will discuss to you today about our handouts number 3 and number 4. So I will have a quick run through of the concepts, and we will also solve the problems that is found in your handouts. So we have here a mensuration of plane figures. So we have here square, so I guess we are already familiar with some of these figures, plane figures. We have the area of a square is given by the formula a squared. So a is the measurement of one edge. Since for a square we have all edges are equal, so that is a squared. For a rectangle, area is equal to the base times the height or its altitude, so b times a. We have also a right triangle. So when we say right triangle, it has one angle that is 90 degrees. So we have area 1/2 base times the height or times the altitude, that is 1/2 BA. We have also the Pythagorean theorem. So this is applicable if you have a right triangle. So given we have this figure, if we have this triangle, we have B and A, and given that your hypotenuse is where the side which is opposite the 90-degree angle, we say hypotenuse is C, so we have this relation as a Pythagorean theorem, A squared plus B squared is equal to C squared. Or if you want to get A squared is equal to C squared minus B squared. So if you want to get the side A, the square root of C squared minus B squared. Or you can also have this C, if you want to get the hypotenuse, the length of the hypotenuse, C is therefore equal to the square root of A squared plus B squared. Again, this is applicable for when you have a right triangle. We have other triangles also, special right triangles. As you can see, the first figure, we have an isosceles right triangle. So isosceles meaning the legs are congruent and it has a 90-degree angle here. So when the legs are congruent, meaning to say that these angles are also equal. So that is the first one. Next, we have another special right triangle. We have 30, 60, 90 degree angles na triangle. No? As you can see, 30, 60, 90 degrees ang iyahang measurement of its angles here. 30, 60, 90. And then the last one, we have the special right triangle 3, 4, 5. And the ratio 3, 4, 5, as you can see in this side, is measured 3. This is 4, and the hypotenuse niya is 5. So it follows the Pythagorean theorem for this one. So say for example, if your hypotenuse is 5 squared is equal to 3 squared plus 4 squared. No? Let us see if this follows the Pythagorean. So 3 squared is 9 plus 16. 9 plus 16 is 25. So 25 is equal to 25. So it follows the Pythagorean theorem. This is a special right triangle 3, 4, 5. Or not necessarily that the measurement are 3, 4, and 5. But in the ratio. In the ratio 3, 4, 5. That is a special right triangle right there. Then we have oblique triangles. So no two sides are equal. So still the same, the area, since it is still a triangle, its formula for the area is 1/2 base times the altitude, wherein the altitude niya is from this point, mag-drop ka o perpendicular line to the opposite side niya. So as you can see, this is 90 degrees. And so, since this side is not known, suppose we have this side as A, this is B and C, we are to follow this Heron's formula, wherein area is equal to this one, square root of S times S minus A, so A is this side, times S minus B, this side is B, and S minus C, wherein this S, this naman na si S, is equal to A plus B plus C over 2. Then we have parallelogram. So the formula for area of the parallelogram is the measurement of the base times the altitude. So imuhang altitude is you simply draw a drop down from the other side to here, perpendicular to the other side as well. We have next is a trapezoid. Area is 1/2 the sum of the bases and altitudes. As you can see, in a trapezoid class, we have ang base niya is where ang bases niya are the parallel lines, this A and this B. And then, so that is why you have 1/2 sum of the bases with the measurement of this and this. And then times the altitude. So for you to get the altitude, you simply draw a drop down and again vertical line between the bases, no, perpendicular siya sa bases. That is your altitude. Next, we have the circle. So circumference of the circle is 2 pi times the radius, the measurement of the radius, or that is if you are given the diameter, so that is pi d, since the diameter is just twice the radius. Diameter is twice the radius. So when you say circumference, it is the measure aning kanisiya around this one, around the circle. When you say area, area is kani siya nga part, kani siya nga whole, this one. That is your area. So formula for the area of the circle, we have pi r squared. Or if given ang imuhang diameter, so you can also use that one. We have here the formula pi d squared over 4. Pi diameter squared over 4. If you are given the radius, that is pi r squared. This one. Next is the sector of a circle. Sector is this part. So if you have like a piece of pizza, so this one is the sector. We have the formula 1/2 times the radius, so the measure of the radius times the arc. So how do you get that? This one, this C, the measurement of this. If you're not given that, then you may use the angle. This is the angle, theta. That is 1/2 r squared theta. Then segment of a circle. What is the segment? This one is your segment. Kini siya nga part. So that when you say area of this, you simply get the difference between the area of a sector minus the area of this triangle. So ang mahabilin is the area of this segment. So area of the circle is given by the formula 1/2 RC, then minus area of the triangle is 1/2 BA. So this is your base, this is your A, altitude of this triangle. That is now, mahabilin this one is the area of the segment of a circle. Then ellipse. So ellipse, as you can see, more siyang oblong o forma. Oval. So formula for the area of an ellipse, pi AB. So A and B right there is like the measurement of the semi-axis. So this is your A and this is your B. So multiply that one and then with pi, A and B. Next is the last one. We have the parabolic segment. So like a parabola, we have this as the length L, and this one is your D. So area of this shape right here, or this figure, is 2/3 the length and the D. Okay. Similar figures, in general, corresponding lines of similar figures are in the same ratio. So when you have a similar figure, you can make use of the concept of ratio and proportion. Okay, same ratio sila. Similar polygons have the same ratio as the squares of any two corresponding lines. Okay, so I guess murag na-discuss na po ni siya last time. Oh, we have now the sample problems for number 1. Okay, we have this one. The section, this figure, of a certain solid is bounded by two concentric circles whose radii are 6.1 feet and 4.1 feet. Find the area of this section. So this section right here, kanina shaded section. So area of the section, that is actually the area of the larger circle. Area of circle 1 minus the area of circle really S. Circle 2. Wherein the formula for area is pi r squared. So pi r1 squared minus pi r2 squared. So common ihang pi, so pwede na to siya pagawas class. That is r1 squared minus r2 squared. So we have to substitute the values which you are given. Pi r1, that is 6.1 squared minus 4.1 squared. So that the area of the section now is equal to 64.1. Since this is in feet, so that is square feet. Please use the correct unit as well. So for areas, that is in square units, and then our unit used is feet, so that is square feet. Okay, next problem. We have the section of a certain solid consists of a semicircle, a rectangle, and a triangle as shown. So it is shown like in a shape of a pencil. Mura siyang pencil forma. The altitude of the rectangle is 3 times the radius of the semicircle. The altitude of the triangle is twice the same radius, and the area of the triangle is 20 square feet. Find the area of the section. So we are to find the area of this section, the total area of this whole section. Okay, let's just name this total area. So we have our shapes, or our plane figures that we have is in the shape of a triangle, a rectangle, and a semicircle. So the total area is actually the sum of the areas of the triangle, area of this rectangle, and area of the semicircle. So half naman siya sa circle class na. So area of the triangle. So let's put the formulas first. This is pi triangle. So 1/2 base times the height plus area of the rectangle is base times height plus area of the semicircle, that is 1/2 pi r squared. No, 1/2 man. Area of the circle is pi r squared, and semi man, so katunga. So that is why we put 1/2 there. Okay, this is 1/2. Base of the triangle is this one, 2r. And then our height is also given to be 2r. Plus, the rectangle's base is 2r as well. And then its height is 3r. Plus 1/2 pi r radius. Ay, dili din siya radius. Let's make use of the diameter since we are given the diameter. So, let's make use of pi d squared over 4. Okay. So our diameter is 2 pi, 2r squared over 4. Okay, simplifying. This one is cancelled, so we have 2r squared plus, this is 6r squared plus, this 2 squared is 4, so this is cancelled. So 1/2 pi r squared. So this is the total area. Now, in order for us to get the value, we will make use of this given. The area of the triangle kuno is equal to 20 square feet, wherein the area of the triangle is nakuha na to siya, no, dinhi nga part. So 2r squared area of the triangle 20. Ito lang is-show 1/2 base times height, 2r times height, 2r. So 20, this is 2r squared. Divide the whole equation by 2. So r squared now is equal to 10. So we may substitute the value of r squared by 10. So 2 times r squared, which is 10, plus 6 times r squared, which is 10, plus 1/2 pi times 10. This is 20 plus 60 plus 5 pi. So calculate. You get now the total area to be 95.71 square feet. That is the total area of this plane figure. Solid. Okay, so next problem. I have a city block is in the form of a parallelogram whose shorter diagonal AB is perpendicular to side BC as shown in the figure. The shorter sides represent streets and the longer sides represent avenues. If the distance between the avenues is 400 feet and the length of each street is 500 feet, find the area of the block. So this figure is already given. We are to find the area of this parallelogram. So that is simply base times height. And then our base, we can consider this as our base. This one. So it is 500, no? Sa atong figure, we consider the base to be 500. So kuha na to si height h, which is this one. This would be our h, which is that is AB. So pangitaon na to si AB. Sa AB. Okay, so how do we get AB? So since we're given this is 500 and this is also 400 and this is 90 degrees, we can make use of the Pythagorean theorem. So CD is equal to the square root of 500 squared plus 400 squared. So CD, therefore, we get our answer to be 300. So this is 300 feet. Okay, so we will also, let us try to find this one. Kani siya, no? Si H or si AB. Si AB. So kung ato ang, if we look closely in our figure class, if we look closely, angle DBC is congruent, is similar, actually equal siya, or tanaw ko ng angle DBC is equal to angle BAC. DBC, so this angle is actually equal to angle BAC. So BAC. Kani siya, big triangle, this one. Okay, so kani ko na siya nga angle class. They are equal. This one and this. So that by ratio and proportion, okay, so we have similar man siya nga triangles. Ang gimin na to ani nga triangles is this and kani siya nga triangle and this also, this bigger triangle. So similar sila. So we can make use of the concept of ratio and proportion, no? By ratio and proportion, mag-ratio ta, we have AB. So AB is to this side. AB is to this 500. So AB is to 500. As may similar ani niya. BD is to this one. So again, we have AB is to 500 as BD is to this one. Kani and this, as BD is to this, which is this one, CD is 300. So BD is to CD. So AB is to 500. Ang ato ang BD class, that is 400, and our CD is 300. So masolve na to ang measurement ni AB, which is now 2000 over 3. So let's just make use of the fraction. 2000 over 3. So therefore, masolve na to siya. Area is base times height. Our base is 500. Our height now, which is AB. So, maoni siya. 2000 over 3. So, the area of this block, which is in a parallelogram shape, is given to be 30. Oh, okay. This is in the form of improper fraction to class. 1 million over 3. And then this is in the unit square feet. Now, we are required. So, kung ato ni siyang para magamay-gamay ang ato ang numerical value, if we convert this one to yard, square yard, so 3 feet class is 1 yard. That is your conversion factor. 3 feet is 1 yard. And then since square man na siya, so square this one as well. So that square feet is cancelled. So you get your unit in square yard. When you do not forget, if you this is 1 million over 3 divided by not by 3, but this should be 3 squared, so divided by 9. So that you get your answer now, 37,037.04. So that is your answer in square yards. Okay.